Today on Capechi's Corner, we're going to start our data analysis chapter, and we're going to look at mean, median, mode, range, and stem and leaf plots. Let's look at the definitions of each of these terms. The mean of a set of data is the average. We're going to add all the numbers up and divide by the number of values there are. The median is the middle value. So what we'll do is we're going to put the values in numerical order. We're going to find the one in the middle. And if the data has an even number of values, we're first going to find the middle two values, and then we're going to take the average of those two. The mode is the value that appears the most often, and the range is when we take the greatest value and we subtract the least value. Get some practice with these terms and using a set of data. So we have 7 numbers here written in orange, and when we find the mean, we're going to find the average. So when I add all these values together, I get 602. I divide it by 7 because that's how many numbers are, and the mean or the average is 86. In a lot of cases in school, that's how teachers find a final grade. They do the average. Test scores divided by the number of tests, and that's your mean. The median is the middle number. If you think about a highway, the median is what is found in between the two different directions of the cars that are driving. So we're talking about the middle. So I'm looking at my numbers, and I have 3 this way, and I have 3 coming from the other side. So my middle number is 86. And trying to find my mode, that's the most often. Now if I look at my values, everything is only listed once. So in this case, there is no mode, which sometimes happens. You could have no mode, or you could have 1 or more values that can be considered the mode. Now we'll take a look at the range, which is our highest value, which is 96, minus our lowest value, which is 72. So our range of values, which is the span of the numbers, is 24. Let's look at another example. It says Carrie's 4th marking period test scores are 78, 92, 84, 94, 88, and 84. And I'm going to find each of these terms. Now, because of this, I need to put them in order numerically. The last group was already in order, so let's do that. So I have 78. I'm going to list that as my lowest number. I'm going to put a little check so I make sure I take care of it. And then I have 84. And then I have another 84. And I have 88 and 92. And my last value is 94. Now, just to make sure I didn't miss any, I like to count to see what I have. So I have 6 numbers to start with, and I have 6 numbers, so it looks like I did not forget anything. So now I'm going to find the mean. So again, I'm going to add all these values up, and I have 520. I divide that by my 6 values, and my mean is going to be 86.7. My median is my middle number, so I go 2 to the left, 2 to the right, and I realize that I have 2 in the center. So this is where I have an even number. I have to add those values and divide by 2. So when I do that, my median, my average of those 2 middle numbers are 86. Now when I look for my mode, I'm looking for the values that occur the most often, and I have 2 values that are listed that are 84, so that's going to be my mode. And my range is going to be my highest, which is 94, minus 78, which is my lowest. So that gives me 16. Now let's look at another question that can go along with this set of data. It says, what must Carrie score on the next test to have an average of 88%? This is something students do a lot. I want an A for the marking period, or I want a B. What do I need on my last test score before the marking period closes? So when I do that, remember, I'm trying to figure out what an 88 average, and an 88 average means that you would essentially get an 88 on every single test. So far I have 6 tests. So if on my next test I would want to get an average of 88, let's see how many points I would need. So I would take an 88, which is my average, multiply it by 7 tests total, which would get 616. In our last set of data, we found that so far I have 520 points. So if I subtract those, then what I would need to get an 88 average is a 96. Now, in a testing situation, you could double check that. Take your 6 values that you already have, add your 96, divide by 7, and you should have an average of 88. Let's look at a different set of data. It says LeBron averaged 24 points per game for the first 10 games of the season. How many points must he score in the next game to increase his average to 27 points per game? So again, let's figure out how many points he has so far. So in the first 10 games, he has 24 points is his average. So that leaves a total of 240 points he scored so far in those 10 games. If we want to increase that average to 27, well, now we're talking about one more game, so now it's going to be 11 games, times the 27 points he wants as his average, and that total gives us 297. So if I take the 297 points that he will need for his new average goal, minus the 240 points that he already has, he will need to score 57 points in his last game to increase his average to 27 points. So good luck to you, LeBron. That sounds like a pretty good game you're going to need. Our next question says, Jake's test scores are 87, 93, 88, 80, and 95. What must he score on the next test to have a median of 90? So this time we're going to look at the median. We're not looking at an average. So the first thing I need to do is I need to make sure these values are in order. So I have 80 as my lowest value, and then I have 87, and then 88, 93, and 95. So right now, my middle value, my median is 88. And if I'm going to have a median of 90, so I have to figure out, I can go either way. So I'm either going to have to go in between my 87 and 88, or in between my 88 and 93, because if I add a score, then I'm going to have an even number of values. Because 90 is greater than my initial value of 88 as my median, I know I'm going to need to go to the right somewhere. So again, let's think about what I need. If I want to have a median of 90, that means I'm going to take 88, I'm going to add it to some number, so I'll make that x. And I'm going to divide it by 2, and that's going to give me 90. Now I can cross multiply, which gives me 180 is equal to 88 plus x. Subtract the 88, and I have x is equal to 92. So let's double check that. If I were to make my new value, if I make my new value 92, and I kind of slide that in here, there's my two middle numbers, 88 and 92, and that does in fact average to 90. So I know that my new score is correct, that I do have 92 is what I need on my next test for Jake to have a median of 90. Now, if this algebra messes you up a little bit, and I know that sometimes can be tricky for students, you can just start doing a guess and check. If I use 88 again, I know I'm going to have an average of 88. Then maybe go higher and go to 89 and go to 90. And you can kind of keep playing around with the numbers in your calculator until you get to the median score that you need. The next type of data analysis we're going to look at is a stem and leaf plot. And how that stem and leaf plot works is our stem is our tens place, or it may run into hundreds or thousands as needed. And our leaf only ever has one digit. Now these values are arranged in order, usually from lowest to highest. So for instance, if we look at what we have, our first value is a 6 for my stem and my 1 for a leaf. That has a value of 61. We also have, for instance, if I use a 9 here and a 9 there, then that value means a 99. Now we can look at this display and ask ourselves a series of questions. The first one says, what is the best score? Well, that will be at the bottom, and our best score there is 100. How many students took the test? Well, all you'd have to do is add up the number of leaves that are listed, because they each represent one test score, and that's a value of 30. How many students scored a 90? Well, now we're going to go to this row where the 9s are, and I can see that there are two values right there that have a 0 as their leaf and a 9 as our stem. So there are two students that scored a 90. And the range of our scores, now again, I can go from the highest score, which is 100, subtract the lowest score, which is 61. So my range of the scores in this history test is 39. Let's look at another display of data. It says, using the stem and leaf plot, which statement is not true? So in a multiple choice question, we always have to pay attention to what we're asking. I'm not looking for a true statement here. I'm looking for a statement that's not true. So we have a key here, which you see a lot, that 1/5 means my stem is my 1 And an example of my leaf is a 5, and that stands for 15 inches. So the plant heights are all listed in inches. So now what I'm going to do is I'm going to look at one letter at a time, one choice, and see if it's true or false. Letter A says most of the plants are less than 20 inches tall. So if here's my 2, so I don't have 20 on there, but I definitely have most of my plants are either in the single digits or the tens digits. So they range anywhere from 1 inch up to 17. So I'm going to say that's true. That definitely looks like most of the values occur below 20. Letter B says the median plant height is 11 inches. So now I need to find the median. So the easiest way to do this is just kind of take some values from the beginning and take some from the end and see where my values are. So if I go, let's say 1, 2, 3, 4, I'm going to cross those off. Go 4 from my other end, and then I'll do 3 here and 3 there. And it looks like my median is 10. So this one says 11, so that one is false. And although that looks like it's my correct answer, letter B, I'm going to just make sure that I read that correctly and I counted correctly, and I'm going to look at C and D. C says the range of the plant height is 35 inches. Well, if the highest value is 36 and my smallest value is 1, my range is 35, which is true. And the last letter, D, says the plant height that occurs the most often, which is my mode, is 11 inches. So if I look at my data, it does look like 11 inches is my mode, so that's true. So using the stem and leaf, the statement that is not true is letter B.